recording? Yeah. Okay, so I wanted to show something that's been the two most useful things that I've found for learning C++, especially at a lower level. The first one is Find, my personal programming assistant. I'm not sponsored by any of these things. These are just because I'm too small and it's not worth it. This one's really great. You give it a prompt. You can put in code that you wrote. You can ask it questions about the code. You can further iterate on questions, which I find very useful. Like when it gives you an answer, be like, "What about this?" If you like, even if you ask it questions about its answers, like if it says, "Oh, pointer, blah 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 blah," you could be like, "Well, don't pointers do this?" And they'd be like, "Oh, here, let me further clarify." That's been really useful. So I would definitely use this. This is really great because I've been trying to figure out how to visualize these things, and it's really kind of abstract in my brain without someone writing it down and drawing it. And I had been drawing it by hand, and I had gotten quite a few things wrong. So I'm just going to show you how this works because I haven't seen it anywhere, and it's been really, really useful. So let's just start by making an integer, calling it x. We'll say x equals 20. Let's visualize it. You can change what language you're using. I think it has just a few. First thing you want to do is change this to byte level view because it helps give you a lower level view. You'll notice stack and heap. This is because we are in main, so this is all going to be in the stack. We have our variable x. This right here and this right here are the values in decimal and hexadecimal. This is the address of the integer variable, and you'll notice that it has 4 bytes. No, not 4 bytes. Yeah, 4 bytes. Sorry. And that's because an integer is a size of 4 bytes. What is 4 bytes? Well, 1 byte is 8 bits. So when we hit next, you'll see here's the first bit, second bit, third bit, fourth bit. To set a variable to 20, we just don't have to write into any of the last 3 bytes. We just set it to 000, 000, 10100, and so that sets it to hexadecimal 14, which is 20. So that's very simple. I think people probably had an idea of that's what's going on when they make an integer. What I found a lot more useful is when you're doing stuff like pointers, int pointer, and we say int x equals 20, and then we say int pointer equals the address of x. Let's have our int pointer point to x. What is going on here? Let's visualize it. Boom, we're in main. We have our int pointer, much bigger than x. That's because addresses can be very large. I believe that's why it's so big. I could be wrong. Maybe there's some other reason, but I think it's because of 64-bit addressing or something. I don't know. So you can see it's an int pointer takes up more space than x because x is just an integer, so it only needs 4 bytes, whereas this needs, I think, 8. 1, 2, 3, 4. Yep. So we create our int pointer here. It's pointing to null, nothing. I don't know if it's pointing to null, but it's definitely not pointing to anything. Create our x variable, and we set it to 20 on the same line. The red line, by the way, is the line you're about to execute when you hit next, and you can go previous to undo stuff, which is useful. So we created our x, set it to 20. Now we're going to set our int pointer to point to x. What will happen? Boom, there you go. What is the value of our int pointer? It's not 20, it is this. You can see how it's set all the 1s and 0s, and this, all of the stuff here, when you take it and add it up or whatever you want to say, when you convert it to an address, it gives you this number. This is the binary for this number, I believe. It should be. I don't know why it wouldn't be. And you can see it just points to this. BD4 is what this says. It says 0xFFF000BD4. That is the first byte of our integer variable. And because it's an integer, it knows that it's going to be traversing by 4 bytes whenever you're doing something like going through memory. And so yeah, you'll notice the pointer contains no information whatsoever as to what the variable's value is. It just contains this address, BD4, BD4. So they're pointing to each other. Okay, that's pretty simple as well. We do something a little more complicated. For me, I didn't really quite understand at first, but again, this has been so useful, it's helped. So we create our int pointer. We're not going to do anything with it. Let's comment it out. Let's create a void pointer. Why are we making a void pointer? Well, that's because a void pointer is size of 1 byte, I believe. So if we create a void pointer, and then we're going to allocate some memory. So let's do our void pointer equals malloc, which allocates memory. Each void pointer points to 1 byte. Well, they point to an address, right? And that address is going to be sort of viewed in byte terms. 1 byte here, 1 byte here, 1 byte here, for like as if it was an array. So if we malloc, let's say, let's do 12 bytes. Malloc takes 12 bytes and it returns a void star. So let's visualize this execution. Go over the comment code. We have our void pointer, and now we're going to allocate some memory. Boom. Here's our void pointer. Again, same size as an int pointer. Pointers just have, it looks like 8 bytes all the time. And it's pointing to this address in space. And you'll notice that this address of 5402040 contains 1 byte. And since we asked for 12 bytes, we should have 12 of these. 11. Well, that's because it starts at 0, 0, 1, 2. But we do have 12. We have 12 items in our little array here. And it is on the heap, which is nice little thing to also know. Well, what if we created a int pointer, call it an int pointer? What if we malloc for the int pointer? So int pointer equals malloc. Now, if we recall, a void star pointer is 8 bytes, or 8 bits, or 1 byte. Int pointer is 4 bytes, which is 32 bits. So if we want, let's say, 3 ints, no, let's do 4 ints, we would need 16 bytes. So we could also do what most people would do, which is they'd say the size of int and multiply by 4. But in this case, we're just going to do 16 bytes. Let's visualize this execution. An error, void star. Malloc returns a void star, as I said, so we have to cast it to an int star. Now let's try this. We can close that. That's just as asking, that's like a give us feedback thing. Boom, create our void star pointer. It's pointing to it. We've allocated 12 bytes of memory, and the pointer is pointing to the first byte in that memory. Okay. Now we allocate 16 bytes of memory for our int. Little different view, wouldn't you say? We have our 4 integers, because they're 4 bytes each, of 16 bytes, and it is also pointing to the first byte. I just kind of got rid of that arrow. Of this memory. So that's interesting. It's like, I see how the arrays sort of are traversed. It's like kind of, it's not really grouping them, but this helps sort of visualize like, oh, okay, so if I did plus plus to my int pointer, it's not going to go from here to here, it's going to go from here to here. We don't have to add 1, 2, 3, 4 or anything like that. When we say go up 1, it's going to increment it by the int pointer. And you can sort of see this when you do something along the lines of, let's take our void pointer and not allocate any memory to it. Let's now take our void pointer and set it equal to our int pointer. And I believe we need to cast this to a void star. I think. Boom, they're both pointing to the same first byte. Okay. What if we did void pointer plus plus? Let's do it a couple times. What will happen? How will it traverse? Set it equal to this. Now let's increment. Look at that. It's going through each individual byte because a void pointer is the size of byte, of 8 bits a byte. These are some warnings. Incrementing a pointer of type void star. Well, let's just pretend like we don't got those warnings because it's more of just like a visualization thing. So if we wanted to set our void pointer equal to the 5th element of our integer, or not the 5th element, if we wanted to set our void pointer to the 3rd byte in our int pointer, could we just do plus 3? Okay, let's see what happens here. What will it point to? It points to this. Very interesting. Points 1, 2, 3. What if we did this? It only increment, it seems to have cast it to a void star and then added the 3. So now let's try something along the lines of this. We'll increment 3 and then cast. Now what will it do? It points to the third element of the int pointer. So it traverses via the type of int pointer, and then we're casting it. So you can see how like things kind of work on a lower level, rather than sort of like guessing. That's what I found really useful, is you can see the code execute, you can see the pointers change, and it is very visual versus what I was using in Visual Studio, which is just the raw addresses, which is not, I mean, there is some sort of a little bit of visualization in the Visual Studio. I haven't found anything that has been this useful. So I just want to share this with you guys. I'm like not even a good C++ programmer. I'm probably just bare bones sort of getting it at this point. And this has been by far the most useful, these two have been the most useful things I've found. I haven't seen anyone talk about this, and I found this on a YouTube short, so I don't take credit for this at all. So I just wanted to share it with you guys, especially if you're trying to learn this stuff and it's been a little bit hazy what's going on under the hood. This has been just absolutely phenomenal, and I really hope that some of you guys, this might be useful for you as well. If I made any mistakes, let me know in the comments, because I'd rather be corrected than say something that's wrong. Or if you guys want to clarify anything, that'd be great as well. And if you have any other suggestions, those would be even more helpful, such as like ways to visualize code in regards to that, because I know that that's something that I feel like really helps. Like seeing is believing, maybe is what you might say. Seeing in this case is understanding. So it's been really useful, and if you have any suggestions for other ways you can kind of go about this, or other very useful tools, that'd be great. Just let me know. Yeah, take care. Thanks for watching. Hope this helps you guys.